Good morning, folks. Hopefully, everybody had a nice, long, relaxing weekend. I know it probably didn't feel too much like a long weekend because considering most days kind of already have that weekend feel to it, being with remote learning and all. But we're back. We're nearly done with 10.3. I have two examples I want to get through today in this video. Um, Homework for section 10.3 is going to be posted. I'm going to give a very, very, very short, maybe 5, 6 points tops uh, mini quiz on the course page tomorrow on just 10.3. So only things geometric sequences and geometric series on that tomorrow. So let's finish up our last two examples. Pretty common application of a geometric series and sequence is a repeating decimal, all right? 0.7, this little bar above it, you probably already recognize that bar above a number just means that after that place value, it repeats those digits continuously forever and ever and ever. So it does not terminate, it repeats indefinitely with the 7 for every place value afterwards. Any repeating decimal like this can be expressed as a fraction. We would like to express it as a simplified lowest term fraction. So the trick in this is considering that this is the same digit infinitely many times is recognizing that this is an infinite series. In fact, it's an infinite geometric series. So the trick here is recognizing that zero point 0.7 with a bar is obviously 0.777777, continuing on forever. Well, the first 7 represents 7/10ths. The next place value represents 7/100ths. The next 7 would be 7/1000ths, and then 7/10,000ths, and so on and so forth. And you recognize because we're dealing with place values, we do have a common ratio of what it is to jump from one place value to the immediate next one. You're multiplying by 1/10. The numerator is the repeating digit itself, 7. The denominator is getting larger because, again, we're multiplying by that 1/10. Because we're always multiplying by 1/10, that's what makes it a geometric series. So we can continue and actually write this as a sum of the geometric series using those formulas from Friday. We have our first term in the sum is 7/10. We have our common ratio is 1/10. We simply now plug in to our formula and begin to reduce. So 7/10 A1 over 1 minus 1/10, 1 minus R. That reduces pretty nicely to 7/9. So 7/9, if you plug that into your calculator, you're going to get literally this decimal. Okay? Let's see a same type of process with a little bit more complicated of a procedure here. So this time we still have this repeating decimal of 2, 3. So there's 2 digits now repeating. And we have this first digit that's not necessarily in one of the repeating decimals. Okay, because notice the bar is 2, 3, not 3, 2. So that first 3 is not actually part of it. So again, we're going to rewrite just the decimal part as a repeating numerical pattern. The first pair, the first combo 2, 3 is 23 over 100, all right, 2300. This time, because we're repeating 2 digits, we have to jump 2 place values to get to the next one. So instead of multiplying by 1/10 like we did last time, we're multiplying by 1/100th from one term to the next to the next. 1/100th jumps 2 place values to repeat the 2 digits. Well, we have A1, we have R as 1/100th. You just need to remember that this repeating sum formula that we're about to see here doesn't include the 3 in front of our decimal place, so we simply just add the 3 on, right? So the repeating sum formula, this infinite sum, is for everything to the right of our decimal place. That is the geometric series. And we get 3 and 23 over 99. Now this is a mixed number. I typically am not a fan of mixed numbers. However, this is the one and only exception all year that I'm going to accept it, mostly because The fraction part of my mixed number represents the geometric series. The integer part, the 3, represents kind of like the leftover chunk of it that's not necessarily a geometric series. Okay? So this is it. I mean, that's 10.3 in a nutshell. We have a couple minor applications with decimals. We have our sequences. We have our series. I'm going to post homework to the solutions to the homework on the course page after completing this video. Look through those. Reach out with questions. You will have a brief mini quiz tomorrow on just 10.3. So only the geometric stuff. Good luck. Have a good day.